All right, then I think we're good to go. I'm looking very much forward to this. Before we start, a few housekeeping items as usual. So yes, the session will be recorded. We will share the link to the video with you afterwards. We will also share the link to the slide deck that Glenn is using afterwards with you, so you can have a look at it and follow along afterwards. As this is a hands-on session, I know sometimes it can be a bit much. So you can decide if you want to just listen to what Glenn is saying today and think about it, and then afterwards do the follow-up. But also Glenn told me that he invites everybody to follow along live as he's doing the session. So whatever works for you. If you're ready and if you want to join live, then you can do that. But as I said, slides and videos will be recorded afterwards, so you just can watch it now and then do follow along hands on at some point later in the future. You have the option to ask any and all questions during this session. So we are live. We encourage you to ask any and all questions. So again, there is no stupid question really, and I'm super happy to have my dear colleagues Jennifer and Martin. You might have seen them already in chat, who help out with questions. If there is time in between a break or in between chapters or towards the end of the workshop, then I'll read out a couple of questions maybe that are particularly interesting for a wider audience live, and we can discuss the answers a little bit together. But don't wait up if anything doesn't make sense to you. If you have a question in general, if anything is not clear, then please use the Q&A function in the chat panel and post your questions there, and then then we can look at those. I see a lot of people from all over the world, so I think we're ready to go. Again, as I said, it will be recorded and it will be shared with you afterwards. So maybe it's time for me to get it over to Glenn. So Glenn, I think if you enable your webcam, you should be able to join the session. Here we go. Hey, Glenn. Hello. How's it going? And yeah. Do you wanna share a few words about who you are, maybe before we dive in?
Yeah, so it's going great. So yeah, my name is Glenn. I am a database nerd. I am a freelance consultant and I specialize in web development and graph databases. I try to combine the two. Not always, but most of the time they are combined. Currently, I work with multiple companies. One of them is ARES Travel. It's an American company based in San Diego. I work with Neo4j, of course, and there is also a German company I work with. So it's becoming a busy schedule, but it's infinitely fascinating. So yeah. Oh, hi, Alex. I met her in New York a few days back. So funny how that goes.
Yeah. Hi, Alex.
Okay.
Nice
I think
to
I'm
see
ready
you
to get
join.
started.
We had a Neo4j live a couple. Well, was it last year? I don't remember, but a couple of months ago. So yes, that was a good one. So yeah, check it out.
Yes. Yeah.
All right. I'll be
the
background from now on. If anything comes up, then I'll ping back into the front. But yeah, enjoy everybody. Have a good time, and thank you very much, Glenn, for the workshop.
My pleasure. Yeah, so the first slide we kind of already had, right? You know who I am by now. I've already introduced myself. So we are talking about graphing. I think mainly it pays to think a little bit about what that really means. A very common problem is just migrating. A lot of people have existing relational databases, and at some point they realize they want to change systems, and they want to go to something like a graph database. And then the question is really, how does this work, right? Usually there are like migration tools, etc. But if you have more specific esoteric situations, which most of the companies do, those tools might not always be do the job correctly. So it pays to just think of this more as a theoretical model as well, and how you would deal with this programmatically. So you should try to use the tools first. But if that doesn't suit you, it may be worthwhile to think about this more abstractly. So the plan of today, it's showing to me that it's loading. I don't know if that means that you guys can't see the next slide. Can somebody confirm if the new slide is on?
The new slide is on. Yes.
Yeah. Okay,
Yep.
perfect. Then that is kind of a glitch on my screen, but that's fine. So, like I said, we will first do a small introduction where I will do some more basic outlining. I think it is a very, very important question to think about: when is it time to migrate? Because the answer isn't all that simple, to be honest. When you decide to migrate, then I've developed an example project which you can either choose to follow along with. It's on GitHub. You can clone it. It's public, and then we'll go more in depth on these cases. Hello, Chiara. Am I saying yeah, Chiara? Yeah. Introduction. Um, First of all, I'd like to just talk a little bit about the experience of why I chose this talk, why I applied for this talk at Notes, because it's something that I'm very passionate about. I've myself as a consultant have provided multiple of these migration services. Um, I am also the driver and the author of the PHP driver, so I'm coming a lot from that angle. I've written much material on this. I've written a query builder that maps the relational to graph, which was a lot more difficult than I thought it would be. And I've done multiple of these workshops. Next slide. It pays to just like, what do I expect you guys to know when we're joining this talk? I expect you guys to know the basics of SQL principles, and I expect you guys to have a basic understanding of cycle or SQL. So yeah, I think that kind of makes sense. It should. It's. I think it's also been uh, tagged as a intermediate level talk, so I'm expecting some intermediate level knowledge, I guess. If you want to get the most out of this talk, you should have some experience with migrating schemas, data systems, the data itself, because then you'll understand and recognize a lot more of the things I'm saying, I think. If you want to follow along, you need to have Docker installed. Of course, you don't have to, but it's going to be the easiest. If you understand what cursors are programmatically, that will be nice, because that'll help you to deal with with a higher volume of data. So a lot of these examples will work up until a certain point, right? Until there are like millions of rows, and then we'll have to think of it a little bit more differently. And if you know about cursors, that'll help. And if you have experience in PHP, of course, the examples I will provide are in PHP, but it's really about the queries and really about the driver. And those will work in almost any language. Um, I think, yeah, I'm kind of like as an outline, and I think it kind of shows why migrating is so difficult. Coming from the PHP world, there is this concept of LAMP. It was the original kind of idea. If you wanted to build a web app, you needed Linux, you needed an Apache web server, you needed a MySQL database, and you needed PHP. And that really hasn't changed all that much in the PHP world. Of course, it does a lot in the Node world, things like that. But uh, really, I did a previous talk at Nodes last year where I just talked about the PHP and Graph ecosystem, mainly the PHP ecosystem. And kind of the point I'm trying to make there is that in the PHP system, a lot of these variables have changed of the original LAMP. People work with Windows, people work with Mac, so it becomes LMW. Apache and Nginx are kind of being used interchangeably. PHP now has been added with JavaScript and TypeScript. But the only thing that is really immeasurable, that hasn't been moved in the PHP world, is it's all still about MySQL. And I would love that to change to something that you have a choice between MySQL and graphs. So if you're interested in that, you can scan this code to see the previous notes talk about this. But what I kind of identified there, the key problem was that the ecosystem oftentimes wasn't fully developed. And even if you have a system that is 1,000 times faster, migrating is a lot more complex than just having naked performance benefit when it's done, because getting there is very expensive oftentimes. And if there isn't an ecosystem there to help you, that kind of introduces even more pain. So I was thinking about this. Even if there is a full ecosystem, there is still a lot that can go wrong, right? Getting to the promised land, getting to the graph ecosystem, and having every single advantage. There are two ways of getting there, really. And without trying to make this political in any way, if there is no proper planning and there is a high need, it's of people jump on the ship and things go wrong horribly. On the other hand, when things are very well taken care of and organized, you got something like automated border control, where you can just scan your passport and you're through. It's kind of like how I think about this. You need to have all the proper planning, all the proper advancements to easily migrate, and that's what this talk is going to be about. So, okay, I kind of got a delay when I pressed. That is why I keep skipping to the second slide. So the path to the promised land, really, the ecosystem doesn't necessarily fully get you there. Proper planning and, more importantly, understanding your own data model does. So I really want this I really want you to keep this in mind. So I'm very confident that a lot of these things can work. But I think getting into that mindset is first, there needs to be some level of confidence, and I guarantee you that every relational database model can be directly translated to graphs. I think that the real challenge is that you need to understand your own data model. And then when you understand your own data model, you'll understand all these concepts, and you'll have a great toolbox to move. And that's what I'm trying to say. These are all patterns which you can recognize, and they all have a solution on how to translate it to graphs, kind of an algorithm which we'll be working on today. The real question now is, when is it time to migrate before we actually start migrating? Because it makes sense to sit down and think about this. I think it is important to keep in mind that this really is a holistic problem. I know it's an overused word, but it's something you have to think about a lot more than just a technical problem. It's also a lot about knowledge within the team. It's a lot about risk versus rewards, getting into costs. Does it provide an actual business value? These are all questions that are really important that you have to be able to answer before it's time to migrate. You have to realize it's always going to be complicated. And I think there are like a collection of indicators within your own technical indicators that you can find in your application that may help you decide whether or not it's time to go to migrate. And I'm not going to make any decision for you, but if I'm going to talk about these indicators, and you're saying yes to basically all of them, you should really migrate. So yeah. The first one, and I mean, how could I not start with this if you have slow join operations? What I just want to say about this, because you've probably heard this 100 times, we're in an intermediate system. Relationships are not a first-class citizen in relational databases, which is weird because it's called relational databases. But what I mean by that is it's all about foreign keys. There is no physical relationship between rows. And getting there and having an actual relationship requires some algorithms to wire everything back together in a join. So yeah, that is something to keep in mind why it's slow. That means that things that are like recursive joins or really big data sets really put a chokehold on your applications. And really how you need to think of this is, if you're doing recursive joins, it's a combinatorial explosion, right? Because every time you recurse, it gets how do you say this again? Like it becomes more more complicated, and the data set grows exponentially, so the algorithm has to work exponentially harder. Um, and the same works with big data sets. The bigger the data sets, the more it has to go through. And so the asymptotic limits on these are not very friendly, especially with recursive joins. I believe the big data set is logarithmic, so it's still manageable until you start to add recursive joins to this. And almost all other indicators that I'm going to talk about are basically going to be suboptimal solutions to this. Hello, Ashwag. It's nice to meet you. Meet you too. So, yeah, keep this in mind, because a lot of these indicators I'm going to show you now are actually things that have been triggered because joins are slow. First one is really straightforward: caching for everything. When I work with web development applications, it's kind of, especially with ecosystems, it's kind of my pet peeve I have with these frameworks oftentimes, is that they really, really very easily grasp to caching systems. Um, the way I think about this, even if the tools are remarkably easy to use them and it's great to optimize performance, you need to keep in mind that premature optimization tends to be the root of all evil, which is an infamous saying. Um, it introduces data duplication, and having flushing problems is a horrible problem to have in complex server topologies. And you see that very often in more bigger systems. As you grow, it's very difficult to deal with these kinds of things. So, um, ideally, caching should be your last option, your final solution. Whereas this is something that in a lot of more modern web application development is something that people grasp to first. And that has a lot to do with the underlying databases not performing the way they should. Another one that I see often is just getting esoteric solutions for very simple problems, and I've been very guilty of this. If you kind of come up with your own indexing system, like I had, like this system where we had where we needed to have recursive joins to go through a hierarchy of articles, which kind of this whole example is based on. I kind of just introduced a whole indexing system on top of that to be able to traverse as what was essentially a tree or a graph quickly. Another esoteric solution is polymorphism, which I'm going to zoom in on later. Materialized views is something that comes up very often. Database triggers, dynamic queries without parameters, which is really a silent killer, or introducing very lazy loading, like lazy loading everything to the point that it just is difficult. I'm thinking of like, if you ever open a website and then you see just some loading cards, you have to wait on those cards to load, then you have to wait for the comments to load. Like, everything takes so much time because everything is so lazily loaded. I think those can be great indicators to think about, because when you're implementing this lazy loading, it's also a high cost on the development team to do this correctly. It's not an easy problem to solve. So ideally, again, these should be things you do as a final option, not a first. And then one that I was actually taught in college, which is the concept of a non-normalized table. I remember sitting in the class and a professor was talking about how important table normalization is, all of these things, only to then at the end of the class say, oh yeah, by the way, if you have like these really small tables that are sitting there, it's very common to just slap them back on another table so you don't have to join them. So you're kind of willfully introducing data duplicity just to improve performance. Not ideal. Then another one, simple one, is especially in beginnings in applications that are just starting out, the data model changes completely. So having a strict schema can work in your disadvantage because you will be hampered by a system with four schemas. You will be continually changing, moving, and splitting tables, and it's an expensive operation. But it's a complicated operation, but it also complicates the CI, having to take into account that these things need to happen before a system updates. So I think these are all interesting things to think about if you're doing these. And then one that I really can't say much about because I'm not a data scientist, I'm a web developer. But what I see oftentimes is very, very complicated data science stacks that move data continuously around. And I would just like to make a side note on the fact that Neo4j is not just a database anymore. It's a platform. It has the database part, it has graph data science, and it has visualization, and it really tries to be get closer and closer. It really is getting closer and closer to being an all-in-one solution for this. I just like to refer to this diagram because I really like it, because it really explains what everything is. Like if you're doing querying and you're having algorithms, you're having graph algorithms, you're kind of engineering your own features. If you're having graph algorithms and visualization, you're doing analytics. If you're visualizing and querying, you're doing data exploration. Only when you do all three, you get this beautiful cocktail, very powerful thing that is called graph data science. So I think it's time for the example project. Yeah, this is the example that I cooked up. It's basically a book system, so a system that has books. Uh, so a book is constructed of multiple articles. Articles can have other articles. Users can comment it. Articles can be tagged, and comments can be another one that is known. And this is something I picked up from more Laravel space. I don't know if this, I've seen it happen, which is having something called polymorphism, which really means that we can't have, uh, like we are going to have this table that's going to refer to many other different tables. So you have two choices then. You either define foreign keys for each of these table, and a lot of them will be just null, or you create something like this, where you have a resource ID and a resource table. So you need some logic, some extra logic in your queries, or some extra application level logic to wire them back together. Not even sometimes in a join, but in like recursive subqueries or something like that. So I like to think of this table, the polymorphic category, is that it's like some kind of data science solution that tries to categorize all of these other items in the database, regardless of what it really is. Is it a tag or a comment or an article? So I hope this is kind of making sense. Having a self-referencing articles, having like this, you can think of that as like if you have a textbook or a book of law, you will have a book, and a book will have articles, and an article will have paragraphs. Really, from a data perspective, they're all articles, but one is one level below the other, right? And in some kind of booking systems, these levels can go very deep, like 10 levels deep, something like that, which is a difficult problem to have or to deal with if you are using SQL, and I can attest to that. Similar with comments. Also, oftentimes you'll see comments being lazy loaded. Why is that? Probably because having to do many recursive joins on the comments table is too expensive. So you'll have to click on it and it'll load the comments for you one by one. So yeah, those are like some key insights, I think. And then having these tags, article tags, articles, I'd like to say that that when it comes to this is what is called a pivot table. So I hope you guys are familiar with this. It basically means that it can have multiple articles, but an article can also be bidirectional. So since foreign keys like only allow one value, it's not like an array of keys you can have. You need an intermediary table, which is this article tags thing. So the key takeaways is we got examples of simple joins, which we'll have to translate, where like comments can have one user. You would just do a simple join to know which user it is. There is a concept of self joins, which we'll have to translate. The example here is articles and comments, hierarchical. A pivot table exists, which we'll have to translate. So this means an article can contain multiple tags, as well as a tag can contain multiple articles. And then there is a polymorphism, which is my favorite example because it's really, really different on how you would solve it in Neo4j. So hold on to I'll be nice. I won't say it. So the example project has some goals. We want to simplify the query. We want to increase the speed. We want to ease migration. That's kind of today, and we'll have in the example project. So I guess this means it's time to go down to. I will share my screen, and you guys can either follow along or join me or whatever it is. I'm going to decide to share my entire screen, if that is possible. Yes. I think somebody has to change the screen. I don't think I have the power to do that. Alexander,
No,
can you change it?
I'll do that once you switched over to another screen, because we get infinite webcam issues if I switch now. Yes.
Smart.
Here we go. Here we are.
Yeah. So let me grab that link from the original here. So this is the GitHub. So I'll open that.
I'll share that as well in chat.
Perfect. So this is the book example. I didn't add anything to this besides installation instructions. So let's just blindly follow those and see what happens, right? I'm going to open a terminal. Let's just make a temp directory. Sure. And we'll start. Then they'll probably want us to get in there. Copy the environment. And then it is just simple as doing this docker run composer install to install the assets. Maybe I'll open it in PHP Storm so we get a better view. It's willing to do that from here. Yes, it is. I'll trust the project. Let me enable
Glenn?
presentation mode.
Glenn?
Yes.
Oh, I think it's gone now. I think there's this little at the bottom of your screen. Sometimes it shows up as the restream is sharing. Now it's visible again. Do you mind clicking on hide, where it says?
Yes.
Yeah, perfect. Thank you.
Perfect. So the project is this. We got an example of migrations. We'll do some seeding to generate the data. Here are some extra resources of read queries, which we'll go over. And these are like classes to help with everything. And the actual migration script is right here. So let's first install everything. If anybody is actually planning to follow along, just stop me if I'm going too fast, because I am now acting like nobody. This will take some time, I think. Let's see. Yes, they're healthy now, so they should start. Yes. So it's installing all the assets. That is done. And now my laptop is going to choke because it's going to want to migrate all of these things. So yeah, let's take a quick look into the migration script. This is really just generating all the tables. This is an SQL. So I'm using a library called Finks for this. I'm creating tables, foreign keys, I'm adding the timestamps, rules, and same with users. All these migrations will look like this. And these things all come together as something once you run the migration script. This should be something very familiar to anybody who's developed applications. It's really just a way to structure database changes. So it ran this, it created all of the tables. We can check that if that is true, I think. Because presentation mode, let's do that later. And then we'll have to run the seeds. Seed everything. It's gonna create some articles and everything else. If you want to look at the seeding logic, of course that is here. So it's a faker pattern. You can see like it generated all of these data within 16 seconds. Here is on ID. Current ID. This is just if you want to rerun it. I just have one check to make sure that it's not gonna choke, and then it'll just create the data. It does it in parts because yeah, it becomes very complicated because it's actually trying to do an hierarchical data set. So it recursively calls itself the previous ID was, which is why it's the comments. I think there should be a little bit easier. Yeah, it's just gonna, it lists all the users and it's gonna randomly assign a user to all of these comments that it's generating. Let's see. Yeah, and again, because it's hierarchical, of all the things I could have chosen, users are, I think, the simplest ones. Yes, user is the simplest one. I'm just creating anywhere between 200 and 2,000 users. I'm really wanting to make this random. So, and then it's just gonna insert it. And just for good measure, because I think it's gonna be more fun to start exploring this way, we'll already run the migration script once, just so we can see what it'll look like in the other database. So let's go back to the README. Let's run the migration script. We'll go through the code of it later. Because having this will allow us to run the queries we desire. Because the way I'm kind of looking at this right now, I'm going to go over the queries you want to run, but that should kind of be looked as like an integration test. Like we're kind of predefining this is the queries we should be able to run, and the data set should comply that these queries make sense, right? So just to show off, if we're designing the queries, let's just already make the dataset comply, even though we'll later program this properly. Yeah, because I'm sharing my screen, I think I can go over to the instance of Neo4j. There we go, Neo4j tests. The password is test if you're working with this. Let's see, right? Let's do a call db.schema.visualization. There you go. And somehow it didn't add any colors, but here is the data set. If you've seen my LinkedIn post, I kind of added a screenshot of this. So you can see really nicely in this data set, if you compare it to the original schema that we saw, that really the category has an actual physical relationship to all of these things that it categorizes. You can see that the relationships have names instead of just having foreign keys. And I think it pays also to just, if you want to work within what is kind of the usual way people work in graph databases, they will make their labels of the nodes in a singular form, and they will go into camel case with the first, like, what is it called? It's not called camel case if the first letter is also uppercase, but you know what I mean. The camel case where the first letter also starts with an uppercase, and relationships are in screaming case, and also they tend to be verbs in the active form, because it's easy to think about that way. Oftentimes you see like article has been tagged by tag, and then the relationship changes, the direction of the relationship changes. It's more confusing to think about. Using the active voice makes things a lot more easier to reason about. A tag tags an article, bam, that's it. A category categorizes all of these other things. A comment has commented on an article or commented on itself, and a user commented on a comment. There you go. So that makes it very simple to reason about in your head if you follow these rules. You don't have to, of course, but it pays to do this over time. Um, so yeah, I think that's kind of like we got our whole application started. I would love.
Quick question.
Yes.
Quick question on this. When you set up the Neo4j instance, did you, where and how did you define the user name and password?
Yes. So it's all coming from a Docker Compose file. So as you can see here, there is a SQL one, a Graph one, and PHP one. So for the graph, to look how easy this is, this container name, the restart, all things. But I'm using Neo4j for the latest version. I expose the ports so it's available on localhost, and then I use Neo4j auth, the environment variable,
Mhm.
and I hard coded it to Neo4j test because this is just for educational purposes. Don't ever do this in real life, because even Neo4j 5 will complain about this and say your password should be 8 levels, but you can decrease it by using this environment variable. So I did that. Um, but yeah, this is truly a horrible idea if you are actually working in in
Yeah,
something
don't
in like an
exactly.
actual
Yeah,
system, because yeah, this is really just for educational purposes.
yeah. All right.
So I hope that yeah, that I didn't.
Thank you. No, that's okay. It's
Okay.
it's just for education purposes. It's fine, but we need to really restate this. If you expose this at some point publicly, and you're working on actual data and on a testing, don't do this.
No. At all, don't do this at all. Like, so I assume a lot of you guys are working with Aura, so those things already are pretty secure with their passwords and stuff. Like, also, just a note on the PHP sites, don't hard code like your very like your connection and your credentials in the code. Use environment variables for this. So even though it's for educational purposes and the actual values inside the credentials are not up to standard, the way is up to standard, because you will see if, for example, in the actual migration script to start, variable called graph.dsn. It's an actual environment variable which is in the git ignore, and you can see here that this has been added. So yeah, you can expand on this with like Vault or other more as like more stronger solutions, but this is like the default work way to work, and ideally you should have some. It should be a very complicated password automatically generated or something like that. So the code you'll see will behave pretty much up to standard, but like I said, the values won't. So yeah, let me just figure out if I can, from presentation mode show the console for well. Let me just disable presentation mode. So if you want to connect to the database from here, it is MariaDB, and the username and password is again test. This password has 3 letters, which is even worse. And then the name of the database is also test. Right, let's test the connection, see how it works. Yeah, it works. So you can see here all the tables, and you can just open it and scroll through the data. Data like this. Just like we can scroll through the data here if you want to just match, for example, all the articles. Is return, and let's just limit it because it's going to give me a graphical example, which I really like, because this will. There you go. This is the how beautifully the hierarchy is being displayed in something like this. So yeah, I really enjoy working with Neo4j because of all this graphical feedback, and on top of that, there is Bloom and a lot of things. But yeah, I'm getting ahead of myself. I should keep check on time as well. But I think we're fine. Yeah, we can take our time with this. So that is one thing. Let's just look at the queries that I really want to talk about. The read queries on this side. So I have made SQL, but I actually also prepared them. So here's like an example of a join. If you want to list all the users with their comments, we can just run this query, like in like an actual set thing I would love to just ask you guys and then just think about it this way. But is there anybody up for things like this, like actually writing the queries? I think that's gonna be a bit. Yeah, if I'm not hearing anything, I'm just gonna keep going. So here's an example of this query which we can run. So this is how a join would be done. But ideally, like we're looking at this query, let's at least write the other query in the console. If we have a data set that has a how is you would imagine article has it oh it's already user, right? So let's just forgot what the name of that relationship is. I can see this here. Commented on. Commented. Let's do this again. Okay, it's not an article, it was a comment. Like this. Yep, there you go. You can see here a visual representation. And again, you can see that some of these comments are hierarchical. So I can zoom in on this. It's very visible. Whereas you compare that with a table like this, it really isn't that visible if there are which comments are like hierarchical and how this all works. You kind of lose that insight. The second example would be a self join, which is really the same as a normal join. Like it's very easy to reason about this. Here we just want to see all the articles. If you run this query, it looks the same. I just select everything in this case, so the data set is a bit bigger. But that's not necessarily a bad thing. So writing a query like this in Cypher would be, again, join a article as parent. Let's call this OA for other article. And kind of a pattern should already become visible. That is that the foreign relationship is a thing that the foreign key becomes an actual physical relationship, which should kind of make sense. The query becomes a lot more simple. And here we get this beautiful thing. I forgot to limit it, so this is what we get. I'm choking my machine because this is now returning everything, or the 300 at least. So let's limit this. There we go. This is way more manageable. Then the other example I'd like to outline is getting the tags. Now we're already up to 2 joins because the article tags has a pivot table, right? If you look at it like this in the data set, let's go back to the slide deck here. You can see tags has an article, tags has article. So if you want to find the actual tags, you need to have like an actual. You need to have an actual tree joins because you'll have to join the articles with the article tags first to get access to the tag IDs, which you can then use to join with the tags. So ideally, it would just like this and query the tags and really I think it's kind of becoming more obvious. These queries aren't really changing, and I forgot to, of course. I really went overboard with these tags. No, not really. It makes sense. Like one tag tends to tag a lot of other things. So yeah, this looks like something that makes sense. Like you can see, these 2 articles have the same tag, which is very easy to think about. But yeah, it won't make a lot of sense looking at this because all of these data has been generated nonsensically, uh, automatically. So yeah, putting this next to a query like this is already a bit more simple. But what really is like the big killer is something like if you have like something like polymorphic categories, because this query really is unfair. If you want to do this, you have to union these queries separately. Unless somebody here has a lot of experience and can tell me right now that I'm doing this wrong, because I have looked into this for quite some time now and I couldn't figure out a simpler way to do it than this. Sorry, my voice is losing a bit. Like you have to properly select all of these things separately. So if you want to combine the articles with the polymorphic categories, you have to filter out and say, I only want the ones in the table with the tag resource table articles, and then I want to match these with each other. So you're kind of, yeah, I didn't use the word join here, but it's the same. It's gonna behave exactly the same because there aren't foreign keys. You can then unionize this and do this again for the comments, and then you can do it again for the users, and then you can do it again for the tags. Really, there were a lot of caveats doing this. First of all, coming up with this was already feeling pretty esoteric to me. I don't think this is how it's designed to do. I don't think that's what was meant to be used for this language. But also, the order of how you select things, that tripped me over for like 20 minutes. You cannot just, it's not about the name, because I thought first, as long as these names are the same, it'll map these correctly in the union. It's about the ordering of the select. So it'll say, I had this issue where I showed like the resource table or the resource all of a sudden had the titles of the or the values of the comments in there, because the comments uh, had had that and on the second position in the columns. So it took me a while to figure out what the hell was going on, because I thought my data was wrong. So if we run this query, at least we get something that is really nice to look at. We have the category name as resources, it has a resource ID, and the resource as a value. So we can see, okay, this is an article. Let's not limit it this time, so you can have a full look. So now we got hundreds of them. So you can see there are comments, users, all for the same category. So at least this is nice to translate to. But now, remember, all these queries are really simple, because again, oftentimes when you break things down and you divide and conquer, you will figure out that everything is a pivot table in disguise, a self join, or just a normal join. And these all become the same thing. And that is also true for this. If you want to have this, all you have to do is write something like this. Match C category that categorizes, and now, oh, categorizes. Um, Anything else. So let's call this R for resource. It's limited before it's gonna scream at me again. Did I write the relationship correctly? Yeah, categorizes. It was in the American spelling. So it's again the same simple query. It's kind of the performance benefits and the simplification that we are trying to aim for. We aren't there yet, because we are going to actually write these migrations to be able to do this, but this is the end result we're looking for. There is a final thing I would love to talk about, and that is going in more in depth into these self joins. Because again, if you look at the query for a self join, need recursive. You better hope that your database engine, because if they don't, you are in a lot more trouble. You will have to hard code a limited amount of joins. So that's a problem. But here we are defining a recursive query, and I don't know why, but technology is so far now, because I literally started typing it, and my artificial intelligence just it suggested this query, and it was nearly perfect from the first try. Nearly, not completely. I didn't even. I just commented this and I started typing, and it just suggested me almost this. So what it's doing here is it's actually passing down the level it is at, right? If it's a root node, that means there is no parent ID, because it doesn't refer to anything up there. It has a level 1 at that moment. But then we're going to unionize this with the other query, which is going to repeat calling itself, where it's going to once again select this, and it's going to join itself, and then it becomes this child query, right? So what it's really going to do is, for every row it matches, it's gonna rerun this query. So you can, if you got like a massive data set that goes levels deep, this is gonna choke like crazy. Every time it's gonna call, you're gonna have very easily thousands of joins, 2,000 joins in one using this. This is not viable in an actual data set, but for now it works because this is a small data set. So this is just for proof of concept. And let's at least, okay, I kind of got confused. Let's again remove the limit to get a better idea of this. So you can see they're all root nodes. Then on level 2 there are these, and it refers. I didn't choose it. You can see how this all evolves. And again, if you want to do this in Cypher, it's a bit more complicated. We're going to have to add one more line, and we're going to have to use a variable matching. So let's just go for our article that has a parent, R for root article. So that's the nice thing. We can have variable path expressions. So what we'll say is you want one or more ad infinitum, and we'll have to limit this. I only want to see the paths where where not are as parents. So I'm like limiting the result set that way, kind of to indicate, to make it the performance maybe a little bit easier. And then we'll just return it, the article and the root article. Of course, and we want to know the depth. So if we want to do that, we can also make a path, and we can say where, I think it's length, the path as level, not length, size. Okay, I'm gonna have to take a sneak peek at my example that I wrote down here, just so I don't waste everybody's time. Length. Oh, I did it on an article, not on a. Okay, there we go. I just wrote it on the wrong one. No, the variable is wrong. It's b. Oh, it's again. This is all live, and I didn't limit this like a fool. Poking on me. Let's run this. Yeah, it's my browser is getting a bit crazy because I didn't limit it. You can see it completed it after 1 millisecond. No, it started streaming records after 1 millisecond, completed after 211, but to visualize it, and that made everything crash. So I'm gonna have to look at this again. This one, let's not run it this time. Let's limit it to again 10. Cool. Again, also the performance benefits. It started streaming in 1 millisecond. Can you imagine what kind of performance this is? It's crazy. And that was without caching. It was the first time I ran it in this database. It was a newly, freshly generated database. It's insane to think about these things. This is like a typical graph problem, and this example is really how I got a very, very similar use case to this. And yeah, it's just a really nice solution. I think if you are a query language, you will see immediately what it does. It won't require any like. It's very easy to reason about because you aren't using recursion. Recursion can be difficult to deal with. Like going back to the original example here, it's true. It takes some time. There is a union. There is a subselect. There is a join. The level gets a figure out. Like, does it actually propagate through the system? Yes, it does, but it takes some time to get a grasp of what is happening here. So, yeah, I think I can just switch again to the slide deck because we're just going to go over it once more. If anybody has questions, I'd love that. Well, I'll keep sharing because I think we're going to have to go back very quickly. Let's see here. Yeah, I just compared them one to another. So let's start the slideshow from here. So I put them next to each other. We had the simple join where you can see that the comments gets joined with the user. I did a group by on there. I limited them. Similar here with the self join. Code wise, it doesn't look all that different besides the fact that there isn't any join anymore. And I think what really needs to be taken into account that the match section of the query really doesn't change regardless of the situation you are in your own database in SQL. The pivot table, the one with two joins, and then the one that is really an unfair example, the polymorphism one. I couldn't even get it to fit into one screen, so I had to put them next to each other. And how beautifully this is solved once again in Cypher. I think the key insight is, and I said this before, all four cases map to the same data solution. They all are just two nodes being connected by a relationship. And then the unfair example, which is how I felt when I was dealing with a similar problem, how to query hierarchical structure. So we can see here that it's really it's complicated, and you kind of have to be a bit of an expert in SQL to know about this, or because it's 2023, you just ask ChatGPT and it'll do it for you. But yeah, still, you would ideally understand the code you're working with, which this isn't necessarily for most people. Whereas this, I'd argue, is. So yeah, let's go into the in-depth cases. I think we need to identify an overall strategy, and these are like the rules that you'll need to have. And it's a lot more complicated than you think, especially if you're not aware of this pivot table, because what I see a lot of people do is they say tables are nodes, and that's it. So they'll say tables are nodes, and foreign keys are relationships. I'd say foreign keys are always relationships, and tables aren't necessarily always nodes. They can also just be because otherwise you're just having one node that just sits there, um, essentially acting like a relationship. Just use it because you can have the same attributes to create that that you would put in a pivot table and anything else your heart desires in that relationship. So it really, really, really is that simple. When you are doing this and you're in the process of migrating, you need in the first step, it's always two steps you do, maybe three, it's an optional one. You insert the nodes with the original identification of the origin database. So what I mean by that, usually that means ID. So it could be a slug, could be something else, right? Whatever the engineers came up with 15 years ago in your application, could be the wildest thing. Something like that will be there, something that identifies it, so you can refer back to it, because you will have to refer back to it. You do the nodes first. That's the most important thing. So that means almost every table, not all, but almost all, need to be inserted. Then you can connect these relationships. You can connect these nodes using relationships. And for that, you will use the original identification in the original database. And this I kind of like to think of as the final join, because at this point, what you're doing is, and Neo4j will actually complain to you if you write this query in the console, is it'll tell you that you're having these comma separated lists, and it'll say, oh, we're about to define a we're about to start a Cartesian product. You are right. The database is right. They are gonna do a Cartesian product, but you are limiting it so that every node has one node mapped to it, using the where part of the query. And so we'll see the examples. So it really is a join, not a Cartesian product, but I guess from a purely theoretical standard, it is a Cartesian product as well. That has been limited. And then you can optionally wipe that database identification from it then, because then you don't need it anymore. Once all the relationship is there, you can just do it that way. So let's go to your first. Okay. Let's go to the first case. Let's talk about nodes. Um, yeah, this is a very typical example. This is a very generic piece of code that'll inject the rows as nodes, regardless of what the table name is or whatever. But maybe it'll pay to just let's see how much time we have. Yeah, I can actually just start a scratch file and we can just go through it. Let's see. Unless anybody has questions so far, maybe it's time to just ask, since we've done 1 hour now. Alexander, did you hear somebody with questions?
So the only question, but maybe we can discuss this now or later, was about will you also talk about how conceptually how to model when modeling data as a graph, what to do, and why something should become a node. I mean, you always can give only rough guidelines, obviously, because it very much depends on the individual data set. But did is there time for that later? Is that planned?
Yeah, I can do that now because I kind of outlined it before, but I'll say it more explicitly again. Um,
Mm-hmm.
if you can, and there are two rules. They are so simple, and they do with 95% of all of the cases. If it's a noun, if you can express the concept in a noun, it'll be a node. If you can express the concept as a verb, it'll be a relationship. So if you're thinking of data stuff, and you're thinking about cars that are being driven by persons, it already write itself, right? A car is a node. A person is a node because they're both the nouns. They're acting upon each other through a relationship, namely being driven. And again, I'm using the passive voice. I should use the active voice. I'm breaking my own rules. The person drives the car. That is really the best advice I can give. That works for everyone. If you are having relationships that are being expressed as nodes, that's like my number one as not. That is my number one red flag. When I see something like that in a data as a consultant, so if I take it.
Yeah, yeah.
If you got something more
Maybe
in
a
mind,
follow-up question
but that is for sure.
from yeah,
Hmm?
cool. No, from me is when you do this when you're in this phase of you have a relational database and you wanna map that over to a graph database, and you do some modeling, some data modeling. Is there a process you would advise in doing you know beforehand, like let's say get a couple of people together before in front of a whiteboard and see what there is to do, or is there something else you say, okay, this is important to do, to assess a little bit before the migration process properly kicks off, some prep work maybe?
Mm-hmm. So I think when it just comes from the data modeling perspective, because it's already going to be complicated, I would use the original schema that we got in doing now. You already
Yeah.
have a data set, and you just migrate it over, map it over to concepts that make sense in graph databases, which is what we're doing now. This is really just the first step. After that, there are two other aspects we have to think of, and that is one, when does that migration actually happen? Like, how big is this data set? And the other one is the code needs to be able to. So you will definitely need in your team developers that have changed the queries and understand it, because even though the data coming out of the repositories and whatever it is, whatever pattern you're using, or your ORM or whatever it is, will look the same, it makes sense that that the team is on board and knows what it does. Because really, why you're doing this is not to have, and that was my point too, is that the team is on board with this, is that not just about but it's also about these examples of variable length querying, things that weren't necessarily even properly possible. So once you got the data set running, you might figure out a lot of other things that you need to change or could be optimized, or that all of a sudden you can show a lot more information at once, those kind of things. So I guess that is those are the things to keep in mind. Most is that the team is on board and that they have some understanding of what is going on, and that the code is ready, and that you plan properly for this migration. Because the way it's like in the form of a script, like we're doing now, something you can run, potentially even in your own migration algorithm, whatever it is you're using, and then like figure out how long these queries will take in production and account for that properly, because it can take days to run, if your data set is big enough.
Yep. All right. Cool. Thank you, Glenn.
Yeah, perfect. Um, so yeah, I was about to start writing some PHP in this case. So let's just original migrate to Neo4j. Let's just make a new one, like the easy starts. I'm just gonna do some examples so you get a feel, and that'll show you how these things can be optimized in the future. So let's say, yeah. So this is a typical driver pattern. You create a driver, you can verify the connectivity before, and so you make a sensical error, and then you create a session, and on this session you run your queries. So let's go, and we have PDO, of course. We'll use PDO directly. I think there we go, and we'll remove all of this fluff. We don't need this anymore. So on the PDO, what we'll do is we'll first need the articles. So what we'll do is there run? Been a while since I've worked with PDO directly. Select star from articles, fetch all in associative form. That makes perfect sense to me. We'll call this articles. Let's see this before it, if the debugger works. I'd love to way we can take a look at this. What'll happen? No, it did not. Yeah, let's not overthink this. Let's not go into the debugger now. But I was just thinking out loud. So we got our articles. Let's just do a var export. There we go. The way everybody writes blog posts, you shouldn't do it. Let's do it like this. And let's run it. Docker compose run php 4j. No, I didn't think of this, but it is for sure loading everything. This looks like it's doing its thing. I was mainly interested in what these keys would look like, but we can look at it like this. These columns look like this. So if we want to migrate this, the easiest form, the foolish form really to do it, especially if you're working with big data sets, is this. You go make a for each over all of the articles. That's article, and then you run and you create them one by one. And this may actually work out of the box because these should map to title, ID, content. Yeah, sure. This should actually work. I think we can add the created at and updated at, which is a pain point you'll see oftentimes because in code base, in the sense of code, the in like the code space or the application space, I should say, is usually SQL databases will return strings and integers as values, and that is it. But Neo4j drivers will return node objects, datetime objects, all these other things. So just add the created ads as a timestamp in here, or we can. Let's start with that. We can at the later point, we can actually during the migration change that to actual datetime object. Okay. Why is this example foolish? There are multiple reasons. Imagine you got millions of articles. That's already one. You're lost if this happens. So you should really put a cursor, some chunking logic, whatever it is. And here we are doing a create query once at a time, whereas we could just pass all the articles at once and just unwind them in parts. But let's run this and see what happens. Also, we can also optimize this further by not using it, because now if we rerun this script, it'll keep adding articles and articles and articles even if they already exist. Or if we put on our constraints, it'll start yelling in my face right now, because I think there will now enter an ID with the same. Let's see. Yep, it's yelling in my face. And why is that? It is saying constraint validation because it already exists with a property ID, because I put in the other script a constraint for this ID. So this already doesn't work because we're dynamically creating this. What we should do instead is merge the article based with the ID and then on create set a.title a.content a.created at a.updated at. I'm going this, and of course this is not written like this anymore. It is written like this. So this is the beauty of a merge, which I don't really add into SQL, but this is also a really nice feature that you get at Neo4j and not anywhere else really. Why is it yelling in my face this time? Invalid input. Because I forgot to add a comma here. Once again, I think it's doing it because it's being incredibly slow. Yep, I guess it did it. So we can optimize this a lot more, right? By saying, let's unwind articles. And then we'll use as article. Yep, let's unwind. I just moved away from the string pattern. We unwind the articles, we merge, and we can now say article.id, article.title, article.content. And let's just make this in like the proper casing, because Neo4j suggests to use camel case for properties because it's kind of is reminiscent of JSON where they do similar things. Does this look good? It does. And of course we remove the for each because otherwise we're running the entire thing. We're passing the articles right in here. Oh, it's because of Docker issues. I didn't connect the correct one. And it's yelling in my face again. What's the problem this time? Let's limit it to 1 so we don't, so our face doesn't get spammed. Again, what is the complaint? General unknown error, line 3, 1, 3. One, 3, 1, 3, 6. Let's just bump this query in console. That way we get a way better understanding of what's going on. What is it complaining about? Parameter that doesn't exist. Yeah, that's fine. What else is there? I'm seeing that I didn't remove the comma this here. And another complaint. Yeah, of course, because key value is article. These error messages are easy to reason about, and it ran so much quicker than the previous example already. And if you noticed, this was just boom, done. So just by not having to like reping and doing all these sockets and whatever, doing the same thing over and over on the network, we can just do it like this. Problem solved. I like this. I like this a lot. Final optimization, I think that is relevant would be limit the input. So yeah, this is kind of, you do a limit and skip. So let's limit 100. Let's do 100 at a time. Skip. Let's not skip. What do you use instead? You have limit and you get I forget. Maybe Google. Offset. There we go. So now this becomes a little bit more complicated, but this is how to optimize it. I'd say, so we go articles, yeah. And then we'll go I is 0. We'll do a do while. Let's make it super fancy. Wait for do while. Do while. Let's put this query in the top. There we go. And then we'll say that we are going to keep doing this until the count of the articles is than 100. Yeah, because if the count is, there's potentially still some more. Otherwise, we just rerun it, because if it's 99 article 0 or 1, we know that it's over because it gave everything it could. All we have to do now is add the I times 100. So this is like a limit offset skip thing. Makes sense. Fetch all. There we go. So optimized version of dealing with bigger data sets. I'm doing it like this. I think it's worth to talk about this. Let's run it again, see if it chokes on something. It did not, and it was again done awfully quick. Anything else about this? I mean, that is why you see the final example that I showed you in the beginning. This problem really maps to any article, right? So I think even, I thought about this, I think this is relatively new. We can do this even. You can completely copy a note. Let's see if this is true. I think this is the case. Yeah, it doesn't complain. You can literally just have this whole value in here. And because of this, we can actually make this even more generic, because if we make this now a function, we can say, okay, give me the table and the label of which I have to map it to. We can make it even more generic. Now, look at this. We can say, okay, I don't care what this is. We'll just inject the table in here. I'm making a mess. Reformat this. Yep. Perfect. I just call this rows. You can see like you can play with all of this. Yep. And then here we go, rows as row. Article will become a label. Yeah, and this is becoming a problem. So let's do again as printf. This is also one of the only times you are actually allowed to use to inject this just in the query like that. Let's call this n for node, row.id. This also only works if they all have IDs as their identifier and not something else. You can keep changing this to your business needs, but I think this is like the final structure you can go to. And let's just call the node mapper. And we'll say we'll do it for articles and articles. Let's see if they know. Yeah, they know users to user and tags to tag. Interesting. Will it shout in my face again? It's not shouting in my face. I like this. It is taking a sweet ass time though. Did I make a mistake in the counting of the rows and the skipping? Yes, I did, to add plus plus. So this is not moving at all. Yeah, and this is just going to be stuck now, isn't it? Now, run this again. Still taking a long time. Shouldn't be. Limit 100 offsets. What's this query looking like? Just again. All of these are just stuck now. This query moving. what's going on. At least this time it selects from tags limit. The tags keep going up and up and up. Let's make this a little bit more readable. And then I think it's time to go more to a structured approach again to keep within the time. Yeah. So the tags are going up and up and up. There are not millions of tags. Why is this different? Why is this behaving different from all the other ones? Interesting. Let's look at the tags. There aren't millions of tags, right? I'm literally seeing 37 rows. Because it's less than 100, and I do this while rows are equal to 100. There we go. Yeah, now it's working properly. Okay, so this is like a quintessential example of like a generic way of migrating this. So let's go back to the structured approach. If I go and share my screen and start a slideshow. So again, here is store rows as nodes. Because I'm directly using a tag in the query like this, it works out to like work with something like an enumeration or something like that. So you have some code safety and complete control of which string is actually getting injected in there. So nothing scary happens. So same with the rows. The rows still are just parameters, and we unwind them. So that makes sense. Yeah, and I used the newer feature here. So let's go to a more in-depth case, which is just having the joins and the self joins. The connection information is important. So we're talking now about two, whether it's coming from the same table or a different one, it doesn't really matter. But we are having some reference from between the two tables that you now have in the nodes. So the connection information is really important in both pairs of the nodes. So for this, again, I said this before, merge is your friend. Merge, merge, merge. I made the mistake the initial time to create. You already saw it blew up in my face from the moment I tried to run the query. Merging will allow you to first check if it already exists. You are, by this way, going to introduce a Cartesian product with a where expression limiting the matches, like I explained before. You are going to do a match between two nodes that aren't connected yet, and you're going to connect them. So you can potentially update the performance of these queries if you're working with big data set with indexes. So what you would do is you would insert the nodes without indexes, then you put the indexes on there, and then you use these indexes to optimize the read part, so the connecting Cartesian product gets done a lot more faster. And at that point, I'd like to say one thing: congratulations, you've just reinvented foreign keys in the graph database, but you've only do this temporarily, because you will use that to combine the relationship in a merge, and then you can optionally remove that, and then you can use limits and result summaries to chunk the query if required. Because if these queries tend to take very long, a really nice feature in the drivers is that you get this object in your results that is called the result summary, and that object contains counters, and those counters will tell you exactly how many things it changed. So again, it's a performance optimization, because looking at the example in the code, what I had to do here in this PDO is I had to query it, I had to return it, and then I had to actually look at these rows, count them to see how many were created or pulled, something like that, right? Because you got these counters in your result set, you can just query that without having to return all of the nodes you've created or something crazy like that, or like counting them. So you get some form of database engine will actually tell you this. So yeah, you can, for example, if you're merging something very complex and it's not dependent on input, you should limit it, and then use a result summary to realize how many times do I need to call this programmatically until we're just done. Let's see, connecting articles. This is the prime example, the self-join. We are having a disconnected pattern. We got a child and a parent. They're both articles, but we're having a word expression in disguise because we're using the ID child parent ID. This could just as well be written as a where between where the parent ID equals parent.id equals child.parent ID. And then we merge it. That's it. And you can see I return the summary so we can use this for later use. And I'll show you this in the code. Looking at these objects. So we got this repository can be done very generically. I've shown you this. But I think when we go to the relationship repository, it's a little bit more difficult to do this generically. So I did this by hand. So you can see I return. This is really nice because if you look at the usage, it is actually a logger that'll tell you that if you've seen when we ran the migration script, it actually told us how many it created because these counters tell you how many relationships have been created. I'm just super curious to run the migrate to Neo4j again because I think I've set it up in such a way that it will create 0 now of everything. Of course, I need to make any typing mistakes. Yep, see? So it's rerunning everything, but because we're using merge, it's not creating anything anymore. I like this. And it looks like I made one mistake in the article text. I'm just going to assume it's a mistake and a bug that I have to solve, but that's just not. So that is why I returned the summary. Then we have the case of the pivot table. Before the pivot table is the relationship in this case. So we are identifying the information with a match Cartesian product, which we again are going to limit to a where expression. All other rules are applied, and then we can optionally remove the pivot table nodes. So let's take a look at this. If you go to the relationship repository, I think we can see one. Comment to articles, connect parent comments, connect comments to users, connect categories, connect text. Here we go. So now we got, if we run a query like this, we can literally, because it doesn't depend on outside input, so we can just run this in our trusty old console. What's gonna happen? Complaining again. Why is this? This complaint you will get when you run the query as well. Here you go. This query builds a Cartesian product between disconnected pattern. If it contains multiple ones, this large automated processing, while occasionally intended, which is our case, it may oftentimes be possible to reformulate the query in a case to use, perhaps by adding a relationship. It's like they're reading our minds. Or using different parts. So, and it complained about it twice because we're doing it twice. So, really, like I said before, there won't be. If we trust our data sets, there won't be an actual collision. It'll behave, and the algorithms will run as if it is going to be a Cartesian product. But because we are limiting it by these tag IDs, and because our data entry is correct, it'll only for each article text create one tag and one article. So it's not going to explode in our face. And we can actually, is it describe? Profile, I think it is. Profile will tell us, see? Profile tells us exactly what we're looking for. This will tell us, okay, it's scanning. Is there actually, it's 0 rows, 0 rows, 0 rows. Why is this? That's streaming 0 rows. Like this thing is a lot more smart. Why don't we, for good fun, remove... Did I remove the article text on this? No. That is why I removed the article text. Yeah, it's not using it anymore. Yep. Because we can't run this query again because I removed this. That is why there are 0 nodes. That's this one. No. Comments to users. Because this will work. This is looking way chunkier. I like this. So what can we see? It's scanning the labels by notes. I'm not very strong in reading this, so forgive me if I'm making some mistakes. It says Cartesian result, nothing anymore, because it's optimizing it because I provided indexes. I think if the indexes wouldn't be here, it would complain about an Cartesian product. So yeah, in the migration, it pays to first insert everything without insert all the nodes without any indexes and constraints, because that way the database is not having to do all these checks before entering everything, and you get the optimal performance. But then you actually want the constraints to be there and the indexes once you're going to rewire everything together using relationships. So for that step, it pays to do the constraints. Go to this migration. Did I take this into account? No. What I should have done is in the script is do this, create them, create constraints, and then do the relationships. So yeah, I think that makes sense. Makes a lot more sense. Should improve performance by a little bit. Unless we are dealing with merge. Yeah. So then there is the other question, because now I'm thinking out loud. It make that much sense if you're using a merge, because it's going to scan for the IDs anyways beforehand. So if you are doing this, you better use create, and at that point, you just better make sure you run this only once, because otherwise you're going to introduce duplicated data. So again, this is one of those trade-offs. When do you do the constraints? Do you do it before or after? The question really is, if you're using create, do the constraints after. If you're using merge, do the constraints before. I think I already thought about this in my head, and now I'm remembering it again. I think I moved this around before. I'm getting a bit of a deja vu. Yeah. So let's carry on, unless anybody has a question so far. All right. Am I still live, or am I just talking to myself?
No, you are. So good. No,
Perfect.
no further questions
Perfect.
at this point. Yeah.
I was so silent, and because I only have one screen, so I can't have the other screen open. So I was like, with my network, I was like, maybe, but thank God. So yeah, in-depth cases, the polymorphism. A polymorphic table really is a pivot table, but there is some application level logic required oftentimes to translate the table names to node labels. So if you take a look again at our original schema right here, zoom in on this a bit, you lose the physical relationship in the schema because it doesn't understand really the concept of polymorphism, but it's a pattern that comes up pretty often. So you can see here that the join, that it's a resource ID in a table that is going to have to join. And so yeah, you can just do it like this. Let's go back. In that cases, I didn't provide the example. So yeah, I said like we're going to go back to the code now, but we're switching continuously between the two. So take a look at the final one in the relationship repository, and we're doing the categories, which may be because now I'm just curious, why did it run it again? Because yeah, it makes no. It's the tagging one that the mistake was in. Okay, we'll go back to the tagging one in some time, because we got the time to do this. But let's take a look at this. Yeah, because the label has been injected in this, in the category. It's very simple, right? all we have to do is we scan the labels of our matches. So we get the so this is really like a join we're translating, right? We get a category that then maps that ID, but then we have an extra check to do because we may be at this point grabbing, for example, the resource ID is 1. The chances are that right now this match as a category has not as an article, comment, a tag, as essentially all of these already matched now. But we're only wanting one of these to have the relationship there about that category. So we will actually have to call the labels function on this, and we're going to check if the label that is defined in the category is in there as well. And then once we got both of them, we categorize, and our job is done. Yeah, and I see that I have a bit more minutes, so I'm going to take that because the final part is going to be also a few minutes. Take a look at the tags. Why did it? I'm getting so confused. Oh, I know why. It's just creating the article tag. I was just confused by the naming. The article tag, this intermediary node gets created, and then by the end it gets removed. So it's continually doing the same thing. So mystery solved. All the queries work. It's just this one that gets deleted afterwards that that we're dealing with. Maybe it would make sense if this is becoming like too big. So if these queries are becoming too big to handle, we can also go over an example and switch this query around a bit, because what we can do is we can filter this and say like, okay, where not. We're gonna, instead of doing a merge, we're kind of gonna go back to create with this kind of functionality, where not, and then we create. So now what's happening is it's only going to create this when it doesn't, it's only going to run this create statement like this. But we can actually now limit it, for example, that it does it only 100 times. And now we get the summary. What we can do is we can get another fancy do while. Summary get counted relationship created is again equal. Let's not make the same mistake again. So now this query will not go crazy if we got like a tagging or like millions of tags. So we just optimized it so we don't like stress the database system too much, because we will be dealing with timeouts or anything else. So yeah, I think this was worthwhile to go over. And just if you unwire the merge back to like a where expression to filter them out and then create, you get the chance to limit how many of them you've actually matched. So yeah, I like this this example going like this. And then I think we're kind of reaching the end. I expected this to take a little bit longer because I was kind of thinking that there would be some questions. So I'd just like to say that let's see where again. For those that are, if you want to stay connected to the community, you can check, you can scan this QR code and you'll straight to the chat. There are always a lot of wonderful people in the chat that will ask any question you have related to graph databases. And then if you want to stay connected with me, my email is glenn@nagels.tech. There I prefer community, so I'm just comfortable putting my number here. And yeah, I'd like to say thank you. Even though I didn't really see them, I was wanting to thank Martin and Jennifer because they were there helping, and of course Alexander. I should have really put Alexander here as well. And I'd like to take the time now to take any questions if they are there.
Perfect. Thank you very much, Glenn. Thank you also for the presentation. Let me, oopsie. Let's do it like this. And switch here to the end. Oops, I can do that. Ooh, things to click through. Here we go. Or maybe actually, let's have this open. Yeah, thank you very much, Glenn, for the presentation. Thank you very much, everybody, for watching and joining. I don't see. Oh well, there's one question from Benjamin. Any tips for avoiding deadlocks?
Yeah, so that's I have to get a specific example for that because I'm seeing a specific case in deadlocks that is related to building a single-threaded script that goes over this. So I don't know, Benjamin, if you could follow up and make that question a bit more. If you could flesh it out a bit, I'd be willing to work with it. I also saw another one, the one that is about why are we using PHP, because the answer that Neo4j gave is really perfect. I'm most at home at PHP. I work with the driver. I would like to really stress this. Last favorite talk on this, and in notes there will be another talk where I will just talk about the driver concepts. So the driver itself is kind of managed the API of it on a top level by Neo4j, and they kind of define what a session object is, what a driver is, what all these other ones are. So if you're familiar with this should really work in any other language, because really what we've been doing is we had one tool to get queries full and one tool to get queries into Neo4j, and that is really the crux of the problem. And regardless which programming language you'll be using, the solution should look very, very similar.
Yeah, totally. I think yeah.
Right.
Absolutely. What you said. Benjamin added a bit more details. Multiple threads adding edges to the same node. Does that help you?
So Neo4j is asset compliant, so you really shouldn't worry about it. I think. Worried about causality, like I think what you if these, so yeah, this also a talk that with the driver. I'm just thinking out of the top of my head now, but when you are dealing with data that depends on each other, they should be done within the same session. A session object really is just for causally chained queries. What you may be doing in a threaded environment is creating multiple sessions that then depend. One session in a different thread is done with something, or that it's checking something only if it hasn't been done to write it, and then two at the same time could be doing this, something like that. If you're using merge, that won't really be a problem at all. But another solution to this would be to really get an in-depth look into what sessions are, because they ensure this causality using a concept called bookmarks. So if you're passing around these bookmarks intelligently within your own application through your threads, you may be able to sidestep whatever problem you're dealing with. But in general, if you're using merges, every query is a one-off transaction. Nothing is committed until the entire query is being properly run. So I don't think anything bad will happen to you if you're in a multi-threaded environment. This is your question.
Cool. Yeah. I hope so. If not, then like Glenn said, check out the community forum, check out the Neo4j Discord, and engage there, ask questions, and find helpful people that are willing to answer questions or to interact with you on discuss topics and find out things and help you proceed. Yeah, so this brings us to the end again. Thank you very much to Glenn for presenting today, for live coding a lot, which was really appreciated, at least by me, but also by many of the watchers. I'm sure that you did that live, that you actually dared to write the queries in this setup. So thank you very much, and thank you for preparing, obviously, all the content. Thank you everybody for watching. If you watch this on demand, then obviously you have the best experience to try this at home, basically whenever you like. The content is available for you to try out. If you watch this live now and wondering, oh, I forgot something, I need to go back, don't worry, we share the video link and we share the slides with you, so you'll get that in your inbox later this week. If you want more hands-on content before Notes happens in October, then we'll be back next week on the 5th of October, so that's the Thursday, with a Neo4j Graph Data Science with Generative AI workshop. Same time, again, 2 hours, 5 p.m. Central European Time, 4 p.m. British, 11 a.m. Eastern, 8 a.m. Pacific, and 8:30 p.m. India Standard Time. So join us there, and register for Notes if you haven't. Share Notes with or one of these workshops with your friends, your colleagues, anybody that is interested. That would be nice. Wish you a great rest of the day, rest of your week, and see you soon. Until next time.
Bye.